All right, today we are going to tackle a core algebra skill, graphing lines. But you know what? Forget that slow, roundabout way you might have learned. We're going to jump straight into the fastest, most direct method there is. So, does this sound familiar? You see an equation like this, and I bet your first thought is, here we go. I have to solve for y. And then you start shuffling things around, adding, subtracting, dividing, all of that just to get it into that y equals mx plus b format. But what if I told you all that work is, well, completely unnecessary? Yep, there is a much faster, way more elegant way to get from the equation, just as it is, directly onto a graph. Let me just show you how different these two approaches really are. Okay, so over on one side, you've got that long way, that whole tangled mess of rearranging the equation. But on the other side, you've got the direct route, the intercept method. And the idea is just so simple. See, you only need 2 points to draw a line, right? Well, this method helps you find the 2 easiest possible points on the entire graph, and you can find them almost instantly. I absolutely love this analogy from the source material. Think about it. Why would you go through all the hassle of moving everything around when the equation is already perfectly set up for you? That's standard form, ax plus by equals c. It's trying to tell you something important. You just have to know how to listen. So let's break down this shortcut. It's called the intercept method, and it's all built around finding the 2 most important points on any graph, where the line crosses the x-axis and where it crosses the y-axis. The whole process is just 3 simple steps. First, to find the x-intercept, you literally cover up the y term with your finger and then just solve the tiny little equation that's left. Then, to find the y-intercept, you do the exact opposite, cover up the x term and solve for y. After that, you just plot those 2 points and connect them. That is it. You're done. Now, theory is one thing, but let's see how this thing actually plays out in the real world. We're going to run through a couple of examples right now to really put it to the test. And here it is, that same equation from the beginning. Let's graph it using our new method. No rearranging allowed. Okay, first step, the x-intercept. We're going to cover up that minus 2y term. So what's left? Just 3x equals 6. That's a super easy solve. X equals 2. So we go ahead and plot our first point right there on the x-axis at 2, 0. Now for the y-intercept. This time we cover the 3x term, and that leaves us with negative 2y equals 6. A quick division tells us y equals negative 3. We plot our second point on the y-axis at 0, negative 3. Connect the 2 dots, and boom, that's our line. So much faster, right? Okay, let's try another one. 2x plus 5y equals 10. Now, when you look at this, you might get a little worried. You might think about getting fractions if you tried to solve for y. But with the intercept method, let's just see what happened. For the x-intercept, just cover up the 5y. We have 2x equals 10. So simple, x equals 5. Let's plot the point 5, 0, 1 down. And for the y-intercept, cover up the 2x. We're left with 5y equals 10. Again, easy math. Y equals 2. We plot 0, 2. Connect the dots, and we're done. And hey, notice that? No fractions. That's because the constant on the right, the 10, was perfectly divisible by both coefficients. You know, the numbers next to x and y. This actually happens all the time in textbook problems. And because we use the intercept method, we never even had to worry about it. All right, let's look at one special case that can sometimes trip people up. X minus 2y equals 0. What happens when that number on the right side is a 0? Okay, so here's the catch. When that constant term is 0, just watch what happens. If you cover the y term, you get x equals 0. If you cover the x term, you get y equals 0. So both of your intercepts are the exact same point, the origin 0, 0. And you can't draw a line with just one point. So what do we do? Well, the fix is actually really simple. We already have one point, right? 0, 0. We just need to find a second one. So let's pick any convenient value for x. How about we just try x equals 2? We plug that into our original equation, 2 minus 2y equals 0. A little bit of algebra shows us that y has to be 1. So our second point is 2, 1. Now we can just plot 0, 0 and 2, 1, connect them, and there's our line. All right, now that you've got the method down, let's quickly go over 2 common traps just so you can avoid them completely. First, and this is a big one, don't confuse the coefficients with the slope. In ax plus by equals c, that number a is not the slope. If you need the slope, you've either got to rearrange the equation the old-fashioned way, or you can just calculate it from the 2 intercept points you found. The main thing is just trust the intercepts. Second, Be super careful to plot your points in the correct axes. The x-intercept goes on the horizontal x-axis, and the y-intercept goes on the vertical y-axis. I know it sounds simple, but it's an easy mistake to make when you're in a hurry. So why did we just spend time learning this shortcut? Well, it's not just about saving a few minutes on your homework. This skill actually has real-world applications, and it sets you up for some serious success later on in math.
Let's take a look at a classic real-world problem, building a fence.
Okay, imagine you've got 100 feet of fencing to build a rectangular garden. The formula for that is 2L plus 2W equals 100. Hey, that's standard form. Now the L-intercept, that shows the maximum length you could possibly have if the width was 0. So basically just a really long, thin line. The W-intercept shows the maximum width if the length was 0. And here's the cool part. The line connecting them brilliantly illustrates every single possible shape of garden you could build with that 100 feet of fence. This skill is also a building block for more advanced topics. I mean, when you start graphing inequalities, something like 2x plus 3y is greater than 6, your very first step is always to graph the boundary line, which is 2x plus 3y equals 6. And the fastest way to do that, you guessed it. Mastering this now is going to make that next chapter of algebra so much easier. So there you have it. You've officially moved beyond that slow, tedious rearranging, and now you have a powerful, direct tool in your math toolkit. So the only question left is, by saving all that time and effort, what more complex and interesting problems can you now focus on solving?